atmosphere might only be a thin veil of gas that clings to our planet, but it allows us to live here, and it is where many beautiful celestial sights, such as meteors and auroras, are created. When we look up on a clear day, the sky glows a vibrant shade of blue. This is because the gases in the air scatter the bluer colors in the sunlight. When night falls, we can see another effect of the atmosphere, the gentle twinkling of the stars. This flickering happens because the moving air above us briefly distorts the path starlight takes to reach our eyes. Every evening, as darkness falls and the sky turns from deep blue to inky black, the wider cosmos comes into view. Glittering stars fill the sky to form a sparkling backdrop for the planets that sail above our heads. Occasionally, a meteor zips across the scene, while night after night the moon's silvery face slowly cycles through its phases. Today, astronomers use powerful telescopes to peer deep into space, enabling us to explore the very distant universe. Here, there are billions of galaxies, each full of countless stars. Perhaps in one of them there's someone else looking up, marveling at the magic of their own twinkling night sky. Have you ever spotted a shooting star? These fleeting streaks of light are formed when a tiny piece of space dust, usually about the size of a grain of sand, hits our atmosphere. The flecks of dust themselves are strewn throughout the solar system, and when they collide with Earth, some are traveling at speeds as fast as 150,000 miles. As the dust crashes into our atmosphere, it squashes the air, causing the gas in front of it to heat up. In a split second, the dusty grain begins glowing and is quickly vaporized as it races across the sky. This is what we see as a shooting star, or to use its scientific name, a meteor. Sometimes a space rock is so big that if it hits Earth's atmosphere, it can survive its fiery journey through our skies without being totally destroyed. When a chunk of cosmic debris lands on the ground, it is called a meteorite. Meteorites come in many different forms. Some are stony, while others are made mostly of metals, such as iron and nickel. Scientists regularly scour deserts and other remote areas, such as Antarctica, looking for meteorites. This is because studying them tells us about what distant solar system objects are made of, and can reveal the hidden history of the planets. On most evenings when darkness falls over Earth's polar regions, softly glowing curtains of light called auroras appear against the black. Sometimes these displays ripple overhead, bursting across the sky with bright, colorful rays. In the northern hemisphere they are called the northern lights, or the aurora borealis, and in the southern hemisphere they are known as the southern lights, the Aurora Australis. These dancing strips of mostly green and red are created when Earth's magnetic field, energized by the wind flowing from our sun, funnels charged particles into our atmosphere. We can't see them with our eyes, but as they rain down into a vast ring-shaped swathe of the atmosphere around the poles, they make the gases there glow. Have you ever spotted a familiar outline or shape in the sparkling stars of the night sky? You're not alone. For thousands of years, sky watchers from cultures all over the world have picked out patterns in the stars, called constellations. Today, the International Astronomical Union recognizes 88 constellations. These represent all kinds of objects and creatures, as well as mythical figures. Star shapes that aren't official constellations, such as the Big Dipper and the Summer Triangle, are called asterisms. Most of the constellations that are visible in the night sky change with the seasons, as Earth moves around the sun. This means the stars we see in summer are different from those we see in winter. Gaze up at the moon on a clear night, and you'll be looking at an object that has billions of years of history etched into its surface. Its cratered landscape tells the story of countless asteroid and comet impacts long ago in the lifetime of the solar system. But how did this ball of rock end up orbiting Earth? That's something that puzzles scientists even today. The most popular theory is that around 4.5 billion years ago, the young Earth collided with another world, the impact was so violent that this second world was destroyed, and huge amounts of hot, molten material were blasted into space. Eventually, the debris clumped together and cooled, and the moon was born. You have probably noticed that the moon looks as if it is always changing shape. Sometimes it looks like a banana, while other times it's round, like a dinner plate. Sometimes it is somewhere between the two. These changing shapes are known as the phases of the moon. The phases happen because the moon is constantly moving around the Earth. This means the amount of its face that's lit up by sunlight changes night after night. The moon is spinning too, but we only ever see one side of it because it rotates on its axis in about the same amount of time as it takes to zoom around our planet. Did you know that sometimes the moon turns a stunning shade of red? Well, it's not the moon itself that changes color, although it might look that way. It's all because of Earth's atmosphere and our planet's shadow. Very occasionally, the Earth, the Sun, and the Moon are aligned in such a way that Earth casts a shadow over a full moon. When this happens, the moon's silvery white face gradually darkens, in what astronomers call a total lunar eclipse. Yet even in full shadow, the moon doesn't disappear from view. That's where Earth's atmosphere comes in. Our skies filter the sunlight passing through them, leaving only the redder colors to make it out into space. Not only that, but the atmosphere also bends that reddish glow into the gloom of our planet's shadow. The result, a copper-colored full moon hanging in the sky. Everyone knows that the Earth doesn't shine, or does it? Take a look at a thin, crescent moon. You'd expect the rest of its round face to be hidden in darkness, since it is night on that part of its surface, and there's no sunlight reaching there. But look carefully and you will see that the whole moon is faintly lit up. Believe it or not, our planet is responsible. When the sun shines on Earth's clouds and oceans, they send some of that light back out into space in different directions. This Earthshine can reach our neighbor, where it illuminates the nighttime lunar landscape with a faint glow. It's just like here on Earth when a bright moon casts its silvery light on the ground. If you had been looking up at the moon a few billion years ago, you would have witnessed one of the most spectacular sights ever to occur in the solar system. A hail of asteroids pounded into the moon, gouging out huge holes, called basins, in the surface. Over time, these enormous scars became filled with molten rock seeping up from inside the moon. Eventually, this cooled and solidified to form vast, open plains. These are the dark gray areas that we can see on the face of the moon today. Early astronomers thought these areas looked like giant pools of water, so they called them lunar maria, the Latin word for seas. This is quite a misleading name, since there aren't any watery waves lapping their shores. Instead, the moon's surface is covered in fine, powdered rock called regolith. When the first astronomers to use telescopes turned these newly invented instruments toward the moon, they were captivated by what they could see. Huge areas of its silvery gray face were covered in enormous dish-shaped pits, creating a rugged and pockmarked landscape. Today, we know that these craters are the result of asteroids and comets crashing into the moon and gouging out great chunks of its surface. One of the most impressive lunar craters is Tycho. When it was formed, the impact was so great that part of the moon's surface bounced back upward to create mountains in its center. With a small telescope, you can even see where debris shot away from Tycho as the asteroid crashed into the lunar rock. These are the bright streaks that extend out from the crater. Imagine what it must feel like to step out onto another world, a place where the sky is pitch black and where there is no air or clouds, so distant landscapes look crisp and clear. A place without trees or plants, where the ground all around is a dark gray powder peppered with craggy rocks and boulders. This is the scene that faced the astronauts who traveled to the surface of the moon on the Apollo missions of the late 1960s and early 1970s. As they took these extraordinary first steps, the moonwalkers snapped pictures, performed experiments, and on some missions even drove a specially built moon buggy. There is no wind or liquid water on the moon to disturb the landscape, so the astronauts' footprints are preserved in the lunar dust to this day.